Hello, everyone. Thank you for coming along. Thank you for coming into the dark from the sun. That's a huge achievement. My name is Mona Siddiqui, and I am Professor of Islamic and Interreligious Studies at the University of Edinburgh. And I have the distinct privilege of welcoming our three guests for this afternoon's event. Before I introduce them, let me first of all thank Amal, which is a side foundation project, and their aim is to engage the general public with Muslim culture through arts and literature. And what we're trying to do this afternoon is just explore the history of maths, but through a specific lens, in a broader context, but through a specific lens, which is looking at the Golden Age of Islam and Islam's Golden Age and its contribution to mathematics. Let me just put this into a little bit of context before I introduce the panelists. At a time when Islam is under intense social and political scrutiny, when the religion is perceived by many as synonymous with terrorism and violence, and I'm not claiming either way, it's wise to step back and see a longer history, a bigger picture. Those of us who are scholars of Islam know the bigger picture, but we are also very sensitive to the current issues, even as we get tired of cliches such as a clash of civilizations, when even a cursory look into history shows how interconnected the world was and is. Civilizations flourish and die, and Islamic empires, like others, were about invention, creativity, big ideas, and coexistence. The great artists, thinkers, and inventors of medieval Islam were not all Muslim, but they contributed to an intellectual environment which saw all knowledge as a search for a higher truth. As Michael Morgan writes in Lost History, to lose the conscious memory of an entire civilization is especially tragic and dangerous, because each civilization, no matter how grand or flawed, is a laboratory of human ideas and ideals, of dreams and nightmares, and we can learn from all of them. So just going back to today's event, we've all heard, I hope we've all heard, of the Beit al-Hikmah, the House of Wisdom, established in Baghdad in 832 by the Khalifa al-Ma'mun. And from that time, I had heard of the famous mathematician, such as al-Khwarizmi and Hunayn ibn Ishaq. What they were all trying to do in their own inimitable ways was to find the divine in numbers. Some, like the 11th century al-Khayyam, were true polymaths, mathematicians, and yet so much more, yet made famous in the West for their love poetry. When I think about these people, their learning humbles and inspires. So within that context and against that background, let me introduce our three speakers. The format is going to be that they will each speak from their particular angle and on a particular theme related to maths for about 5 minutes. We will have a discussion amongst ourselves, and then at the end, for about 20 minutes, there will be Q&A from the audience. Can I just ask how many of you are mathematicians yourself? Professional mathematicians? Okay, not many. You are allowed to ask any question apart from asking us to do a sum. And I would also ask you, to try and keep your phone on silent and only tweet nice things about us. So let me introduce you to the panel. Marcus du Sautoy, Professor for the Simony, Professor for the Public Understanding of his Science and Professor of Mathematics at the University of Oxford and Fellow of New College. In 2016, he was made a Fellow of the Royal Society. He's known as the author of 4 popular science books, including his most recent book, What We Cannot Know, 2016. He's presented numerous radio and TV series, including a 4-part landmark TV series for the BBC called The Story of Maths. He worked extensively with a range of arts organizations, bringing science alive for the public, from the Royal Opera House to the Glastonbury Festival. And in 2009, he was awarded the Royal Society's Faraday Prize, the UK's premier award for excellence in commuting science. He received an OBE for services to science in the 2010 New Year's Honours List. Welcome. Professor El-Gomati, who's sitting in the middle, obtained his BSc degree in physics and maths from the University of Tripoli in 1970 and went on to study for his MSc in California and PhD from York. He became a professor in electronics at the University of York in 1997 and his research interests in surface science and electron optics, with particular emphasis on the development of novel instrumentation for nanoscale structure and analysis. I don't even know what I'm reading, but still, never mind. He's the author and co-author of more than 200 articles and patents in these fields. Welcome, Professor Gomati. And Amira Bennison studied history and Arabic at the University of Cambridge. She went to live in Cairo for a year before studying for a master's at Harvard University and her PhD at SOAS. Her PhD, based on a year's archival research in Morocco, looked at the impact of the French conquest of Algiers in 1830 on notions of political legitimacy in neighboring Morocco, and was published as Jihad and Its Interpretations in Pre-Colonial Morocco. She too has appeared in several TV programs about the history of the Middle East and North Africa, including Europe's Lost Civilization, The 30s in Color, Islamic Science and the Ottomans. And she's also a regular contributor to Radio 4's In Our Time. And amongst her publications are The Great Caliphs, 2009, and the Almoravid and Almohad Empires. Before I ask, and I'll start with Amira, I just want to say I failed maths as a GCSE student, and I'm not ashamed. Well, I am ashamed to admit it, but I just want to say the reason I then went on to pass maths was simply not because I had discovered a love for maths, but simply because a teacher could communicate maths to me. And I think all three of us, all three of the panelists, are people who know how to communicate their subjects and how important that is for education today. So it's a great privilege to have you here. Amira, Thank you. Amira, can I start with you and ask, what do we even mean by the Golden Age of Islam?
Yeah, well, first of all, I'd like to say what a great pleasure it is to be here talking to you today. I'm a little perturbed by how low the lights are, because I feel like I'm talking into a void. But anyway, I'll do my best to speak to you as if I could actually see you. The Golden Age. When we say that in terms of medieval Islamic civilization, we're really thinking about the kind of culture that developed in Baghdad from about 750 to 950. That was the height of what's called the Abbasid Caliphate, a dynasty that ruled over a vast area, which straddled a lot of the territories of older empires, including Sasanian Persia and the Byzantine Empire further to the west. One thing I always tell my students that you have to understand about Baghdad in this period is that it's a new town. It's brash, it's bold, it's just been built, it's full of people from all over the new Islamic empire, it's ruled by a fairly new regime, and it actually has a lot of nouveau riche people who want to make their mark in some way. It's also full of people of different religious backgrounds, different cultural backgrounds, speaking different languages. But what's key to the success of Baghdad as an intellectual center, promoting maths among a whole range of other sciences and arts, is that everybody uses Arabic as the language of science. So in the same way that today English is a global language of science, in this period, Arabic was emerging as a really important language that everybody used to communicate scientific ideas, as well as religious ideas, political ideas, and philosophical ideas. So it's what we would call a lingua franca. And because everybody's using the same language, it means people of very different intellectual, cultural, and scientific backgrounds could pool their knowledge. And that's one of the things that makes Baghdad, during this period, the site of what we call a golden age in cultural and scientific terms. So there's this enormous number of people, and one of the main things that they were doing was actually translating a lot of knowledge from Greek into Arabic. And a lot of the people who were doing this were actually Christians who knew Syriac and or Greek. So there's a whole process of translation of material from Greek into Arabic at this time, in addition to the translation of other materials from Old Persian and also from Sanskrit into Arabic. And a lot of people tried to make their way in this sort of dynamic new society by getting involved in the translation movement. If you were a new man and you wanted to make your mark in Baghdad, you would become a patron of culture and learning. And to give you some sort of sense of that in a more sort of concrete way, if we take, say, one family, we have a lineage called the Banu Musa, the sons of Musa. Now, Musa was Persian in origin. Some of the sources actually describe him as a Persian aristocrat who fell on hard times. He converted to Islam, prayed in the mosque regularly, but then also supplemented his income as a highwayman. Who knows? Anyway, his sons were orphaned. I don't know whether he just died naturally or he got caught robbing on the highway. But anyway, he left these sons, who were actually then supported by the son of the ruler of that time. And they became courtiers, they became men of the court, highly educated themselves. They became really interested in science, including mathematics. They were particularly interested in engineering. One of them composed a book called the Book of Ingenious Devices, which, amongst other things, showed you how to get the optimum combination of wine and water in a single vessel through complicated pouring mechanisms, which seems flippant, but it was engineering techniques which could be applied more widely in society as well. But the Banu Musa are important because they also went searching for books. They sent missions to Byzantium to collect books that could be translated. They paid translators. And they also found one of the key mathematicians of the era, Thabit ibn Qurra, who was a young man who was actually a money changer in a place called Haran in northern Iraq. They took him from Haran, brought him to their house, and educated him and supported him, and he went on to make massive contributions to mathematics. So that's just one example of the kind of culture which was very common within Baghdad during this period, and why we call it the Golden Age. My final point would simply be that one of the reasons Muslims of this era were so interested in knowledge was that there was a kind of research culture in the air. And they also wanted to apply this knowledge in the same way that we want to learn things to apply them to life in various ways. Muslims of this period are very creative and wanted to apply their knowledge, including mathematical knowledge, to tax collection, to astrology, to architecture, to a wide variety of things. So this is why we call it the Golden Age.
Thank you, Amira. Thank you. I think I'll leave my questions till the end when all three of you have spoken. Professor Gomati said to me he wanted to tell a joke as well, but I think the theme of his 5 minutes is going to be mass and migration.
Right. Well, thank you very much. But the Golden Age to me is, I don't know what carats gold are you measuring with. Mine is 24 carats, and actually goes from 750 to well over 1600. And I can go over and say why has it been so rich at that time, well beyond the 1100 or even the 950 as Amira, but I'm pretty sure Amira has a reason or two to say it's 200 years. To me, why has the whole thing been so developed so richly and so beautifully at that time? And to me, I find two things. One is the first of them is the stable state. Rich, like we are rich at this moment in time in the West. The UK in particular is very rich. But the second one was, as Amira was also alluding to, the migrants, at least the migrants to Baghdad. And there were no executive orders to get rid of them. So they were welcomed, and they were paid, and paid handsomely. The Bayt al-Hikmah, as Amira was referring to, there are some saying that they were giving gold in exchange of the books that have been translated. But they were actually, even if that was not true, they were actually looked after very well indeed. So to me, a state which is stable, and then the translation of the books coming from the West, coming from the East, Indians, and which pre-existed the work of Muhammad ibn Musa al-Khwarizmi with his book, which is so fantastic, and I'm not going to dwell too much on it because I know that Marcus would like to speak about him, so I'll leave that to Marcus. But actually, the word itself, which we are living with today, algebra, coming from his understanding of the equation. So you reduce the equation to very elementary parts, and then use the word algebra, which is composing, and al-muqabala, one against the other. So the two sides of the equation. That was fantastically important for the development of equations as we see them and as we use them today. The second one was the translation of the Greek knowledge, and which actually, again, started to do the myth. Alexandria, or the guy from Alexandria, Archimedes, who have composed these mirrors to burn the ships which were coming to one of the cities in Greece. And the Arabs and the Muslim scientists at the beginning looked at all of that and said, well, can that happen? Is it possible with mirrors? And then they actually worked very hard. And you find people, mathematicians like Abu al-Ala ibn Sahl, who is true mathematician, all in all, but working on that and then coming with the idea of having just the mirror, but also with lenses. And that was taken over later on in the late 10th century, beginning of 11th century by Ibn al-Haytham, who done fantastic work that we are still using some of his discoveries today. And I earned my living as an electron microscopist or developing electron microscopy to deal with stuff that he has discovered for us and pointed out to us, like spherical aberration, for example, in lenses. And the camera, and whether it is the camera obscura or the pinhole camera or whatever it is, it doesn't really worry me. All of these people have tried to do things which is for the good of all. And I can dwell on that later on, but I think my 5 minutes have been up. So I'm not going to take any more of that, but I can talk about that later on.
Professor du Sautoy, you're going to talk about, well, at least start with, is there a history of maths?
Yeah, I think I made this program, as you said in the introduction, called The Story of Maths. And it was quite a revelation for me, really, because I think we tend to teach mathematics, certainly at university and I think at school, in a very ahistorical way. I think most students kind of have this impression that there's some textbook which has dropped from somewhere, from the sky or something, and then we teach what's in this textbook. But what I've discovered through making that program, and actually through the books that I wrote, the first book that I wrote, The Music of the Primes, I'm not a natural writer, and I wrote a very kind of narrative which made sense to me, which was a kind of mathematical scientific narrative. But my editor was a historian, and he said, I just can't make any sense of this at all. You're jumping around from century. You know, the narrative that people are comfortable with is a historical narrative. And it started to help me to explore, actually, that mathematics does have a history, something that I was kind of not aware of. So the making of this program, The Story of Maths, was a kind of journey of discovery for me as well, and has benefited me as a mathematician, interestingly, to understand how new ideas emerged. And I think that's what's interesting about this period, to see, you know, what emerged, why, because as I'm going into new areas of discovery, to help me to look back at how people made new things out of old things, it is really helpful. Now, the story of maths, we did 5,000 years. Mathematics really starts. I mean, you mentioned taxation. Taxation is really where it all starts, because you've got ancient Egypt, Babylon. Suddenly, the city-states are emerging, and they need to build. They also need to tax the land. So the discovery of pi comes from the fact that the Nile curves out circular areas of land, and you've got to have the area of a circle in order to tax the farmer. So I think these developing civilizations are real drivers for mathematics. So the first program was about the ancient world, Babylon, Egypt, ancient Greece. And I think for me, I certainly knew the ancient Greeks. Of course, that's where maths really started, because the great proofs are from the ancient Greeks. And then I had this kind of impression, and then everything went quiet. Alexandria library gets knocked out. Everything goes quiet again until Fibonacci. And basically, history kicks off again with a kind of renaissance. And so making this program, The Story of Maths, the most exciting episode was the second episode that we made, which was about the mathematics, the mathematics of the East, not just of the House of Wisdom in Islam, but also China, and perhaps most importantly, India. Because I think this, you've got the trade routes taking these ideas from China, India, through the Islamic world, and of course that's what ends up with somebody like Fibonacci taking them from North Africa through to Europe. And so what are the big transformations that happened during that period? What new things are happening? One of the most significant, of course, are the numbers that we use. So we call them the Arabic numerals, but they really should be called the Hindu Arabic numerals, because we see that they're beginning to be developed. I went to, for example, Gwalior, in just halfway between Agra and Delhi, is a place where a lot of the shapes of these numbers were forming. But this is a number system which is a place number system, which had been there in the Babylonians. But probably the most important thing that came out of this period was the creation of the number 0. And 0 is emerging out of a culture. I mean, it comes from sort of Indian culture, but the fact that the Arabs pick it up and see that this is an incredibly powerful tool in being able to do very fast calculation. You don't need an abacus. You can keep a record of these things. And I think it is significant that if you look at this, it's coming out of a culture that is not scared to think about, I mean, you mentioned the void. We're talking into the void of this dark. But they weren't scared of the idea of the void. They weren't scared of the cosmos, of the idea of the infinite. So I think that's one of the really key things. The other one is this idea of algebra. Because there's already an algorithm, which also comes from, we can hear those al-Khwarizmi. But this is the creation of a language, a new language to be able to articulate structure in mathematics. And I think the idea of translation being important, that the word is a key element of that culture, is what helps you to then say, well, yes, I'm going to, I've spotted a pattern in numbers. If you take number 5, square it, it's 25. But you take numbers either side, 4 and 6, multiply those together, it's 24, that's 1 less. This works whatever number you take. 7 squared is 49, 6 times 8 is 48, 1 less. Why does that work? And suddenly, with the power of algebra, you're able to understand the grammar of numbers. There's the examples, but this gave us a language which had been missing. The idea of having a representation for any number x. I think it was a development of a new language which led to a transformation.
Excellent, thank you very much. Though your sentence, taxation is where it all started. As a professor of divinity, I cannot agree with that. Taxation is where it all started. It started somewhere else, but I see what you're saying. Professor Gomati, earlier on you said to me that you're a physicist, not a mathematician. And I want to probe that a little bit more. What is the difference between physics and maths? But you also said physics cannot live without maths. Do you want to say something about that?
Yes. I mean, there is a table between a mathematician and a physicist at the moment, but we can ignore that. I think it comes to me with how we started the whole development of that part of the science. And people in the beginning didn't see the boundaries that we impose on sciences as we do it today. If you look at Isaac Newton, for example, with his famous book, it is the mathematization principles of natural philosophy. He's famous book of 1617. To great many days, and unfortunately I've just looked at before I spoke this afternoon, most physics departments used to be called natural philosophy, departments of natural philosophy. They are now all physics departments. Ibn al-Haytham, in my opinion, the Arab scientist of the late 10th, beginning of 11th century, was behind the mathematization of science in such a way that we could not do physics or many other disciplines without having mathematics as the underpinning pillars of the technology.
Okay.
So that's how I look at it. And
Do
I
you
keep
want
good
to add
relationship
anything
with
to that, Marcus?
Yes, I think actually, of course, a lot of this mathematics grew out of trying to understand our physical universe, to change it, so the ability to build new buildings led to the development of the need for new tools. But I think you can see already, for example, in Babylonian mathematics, suddenly people are starting to get interested in problems for their own sake. So you see problems being posed about, I mean, already this, the kind of mathematics for solving a quadratic equation is already in the Babylonians, but it's only with the language of this period that we are able to articulate that as an algorithm, which is then in a language that we could understand today. But already the kind of problems that were posed, they would say, you know, suppose the area of field is 60 units squared. You know, one side has x, the other one is 6 units longer than x. What is x? And you think, hang on, how do you know the area of that field if you don't know x already? So it's kind of, you realize they're just posing problems that have no, kind of sound like they have a practical source, but really are just like people beginning to play with puzzles to their own sake. And that's sort of where algebra I often feel is a bit like a cryptic crossword, that you get given some sort of challenge and you've got to unravel this thing to find what the x is. So I think that physics, trying to understand the physical universe, is often the beginning of the mathematical journey, but then you can see so often people just enjoying mathematics for their own sake, but then it comes back down again. So much of the physics of the 20th century depended on just mathematicians of the 19th century who were just enjoying mathematics for its own sake, but then Einstein could not have done what he did in relativity without someone like Bernhard Riemann and Gauss, who just were exploring geometry for its own love.
You see, we could have maybe some brilliant mathematicians in the audience, but for a lot of us, why is maths so hard? What is it about maths that seems so hard? And why are we, relatively speaking, not good at maths in this country?
Well, I think partly it's one fault is this badge of honor, which, you know, you were quite happy to stand up there and say you were bad at maths. You see, I think certainly in my visits to China and India, even if you were bad at maths, the culture is such that you would not admit that. So I think we need to start changing the culture.
I had to say that in case anyone asked me a question.
I know, exactly.
It was self-defense.
But I think part of it is about in the title of this whole session, which is the story of maths. And we don't celebrate the stories. No. We give them the very technical side. We tell them how to solve a quadratic equation in school, and people say, well, why? What's that useful for? And we don't give them the backstory, which I think that's why the story of maths is used in a lot of schools. They take little excerpts from it and show it, because the students suddenly, if they see where it's coming from, it just brings the whole thing alive. So that's my go for the big stories, not the grammar. You know, my son does. You know, when he was at school, he studied Shakespeare, romantic poetry. In maths, he just did the technical side. Where's the Shakespeare?
Before I open it out, I just want to go back to Amira. Yes. Do you want to add?
Can I add a bit? Go. Ladies first.
Thank you.
And can you also say something about the patronage of that time that allowed people to flourish?
Yeah, I mean, in a sense, I was...
Are you going to talk about the difficulty of mathematics?
The difficulty?
Yeah, I'd like to comment on this one.
Okay, very briefly.
Just a very briefly one. Actually, and perhaps Al-Khwarizmi is to be blamed for that, because he combined the two sides of mathematics, the abstract and the applied. And the Babylonians and the Indians were, and so the Greeks, were masters in the applied part of it, but not the abstract. And we have to realize that there is a difficult part in mathematics, the abstract. If a good teacher is around, he or she will make it easy peasy. But if there isn't, and we are not paying the teachers well, you will not get the good teachers to make it
That's
nice.
a political point, I'm assuming. It's
I'm
not a
sorry,
mathematical
I'll
point.
withdraw this
That's
one.
fine. Amira.
Well, I mean, one of the things I wanted to say actually is, of course, that in the era I was originally talking about, sort of, and it can go beyond 950, it can go 750 as long as you want, really, but it's just this that you don't have the sort of same sense of subject specialization that we have today. For people being educated in that time, it was normal to start with language, to think about grammar of Arabic, build up your skills of argumentation, and then move on to something that looked a bit like the classical Greek set of subjects, where you would naturally engage with mathematics. You would see that flowing into a study of the world around you. You would see it connected to music. You would see it also as being connected to philosophy. So well-educated individuals would have quite a high level of mathematics and would think that that was normal to have that. And they wouldn't necessarily separate it out from the other aspects of knowledge they pursued. So you have all these individuals who, although they're in 8th, 9th century Baghdad, they're almost like Renaissance gentlemen in the sense that they can do all kinds of things. You know, 1 minute they're thinking about jewelry design, then they're thinking about maths, then they're thinking about the meaning of the universe, God, and all kinds of other things. The patronage question. Yeah, and this goes back to what Mohammed was saying about a rich society. You know, there were people who really wanted to pay for this knowledge. They were probably more general than our current research councils in terms of putting money into research, exploration of knowledge, and they really considered it something that was socially important to do, that you must support science, you must support learning, you should put money into it. So yes, so I think that's the most important thing about patrons.
Shall we take some questions from the audience? I'm sure there are some questions for our panelists. Yeah. There are mics somewhere. One here. Yeah. Any questions?
Yes, working.
The question I'd like to ask is the digital revolution is hitting everybody, but it seems to me that by using graphical user interfaces and icons, a lot of students today are losing track of the way in which digital machines operate. And there are huge opportunities today, and yet there's a discontinuity between making things easier for students and yet hiding what goes on inside machines, digital machines.
Okay, shall we take another question as well? The lady who was sat there. Yeah.
Do you think we would have better mathematicians if we had a more rounded classical education where subjects weren't separated so much?
Thank you. Do either of you want to take any of those questions?
Yeah, I think you've already kind of illustrated that, yes, it does create a much better atmosphere if we break down these boundaries between subjects. And that's, I got asked by Wired magazine to write a postcard back from 2024 about what I hoped my dream of the, how would the world look like? And I chose education, and I said, I hope we come to a point where my kids don't realize that there's a difference between these subjects. They go from the history lesson to the maths lesson to the music lesson, and don't realize they're totally interconnected. And then I discovered a year later that the Finnish education system is beginning to explore. I think we big up the Finnish education system a bit too much, because I worked with some Finnish educationalists and they said, yeah, your newspaper's always right that we're doing amazing things and wish we were. But I think they're already beginning to explore this idea of just cross-boundary, and it would just help all of these subjects. It's interesting, the digital interface one, you see, that might be an example of a moment, we certainly do find that we don't necessarily need to know the maths that's feeding into our digital technology, but I wonder whether there's a chance for a shift in a new way of interfacing meaning that it may not just be through language, but through graphics. Is this a moment when a new sort of language will emerge because we've got new technology that will allow a different way to create and think? So I think there's very positive sides about the fluidity that this is allowing us that might see changes in ways of thinking, which are not necessarily negative.
Sorry, go ahead. Just very
I think
briefly.
a lot of people have been caught out, even professional people, with virus infections worldwide, and there seems to be a lack of fully understanding even basic IT problems amongst sophisticated professional people.
You're not referring to the recent BA crisis, are you? Okay.
Well, that was that wasn't the yeah.
We don't know what that was.
Yeah.
Okay. Okay.
I think Marcus is right in the sense of also when I'll give you another example. When someone speaks and you say, well, that's gibberish. Do you know where is the beginning of that word coming from? Well, yeah, but it's why? It is Jabr ibn Hayyan, who was a chemist, who was writing chemical equations. And people look at them and say, well, what kind of nonsense is that? Oh, it is Jabr. And then the word Jabr became gibberish, because they didn't understand the language. So today, there might be, and I also don't like the short humiliation of the English language in the new texts and stuff like that, because we will lose the beauty of the language. Similarly, in science and in technology, there needs to be a good understanding of the basics and the underlying principles. But it's a new technology, perhaps, and it may, as Marcus was saying, bring us into a new language that people can communicate with much easier than the languages that we are using today.
Any other questions? Please, the lady at the front.
You talked about the sons of, sorry, I can't remember his name.
Musa ibn Shakir.
Yes, thank you. What about the daughters? What was happening with the women at this time?
Well, that's a good question. We don't know as much about the daughters as we might like. We know there were educated women in this environment. They didn't write so much that's been preserved, and most of the historical chronicles focus on men, but we know that there were eminent men who educated their daughters and wanted them to have a high level of education. So it's kind of they're clearly there, but we know very little about them. So there's not very much I can say, and I know more women literary figures than women who were scientists. But in most places, if you sort of go down in society, if you move away from the elite, you would find that there would be women who were working in an enormous number of professions, but serving women rather than men. So there's a certain parallelism in some place where you'll have female librarians, female scholars, but they're primarily teaching women, with some exceptions.
Okay. Mohammed.
Yeah, I can comment on this one more positively, perhaps, being a man. And the first one who comes to my mind was the lady that Umar ibn al-Khattab appointed as the one of health and safety almost in the souk, a lady. And then the other one was Maryam al-Istirlabi, who was the chief scientist equivalent at the time of Sayf ad-Dawla. And to play with astrolabes, you've got to master at least three trades: mathematics, astronomy, physics, and mechanical engineering, to make the astrolabes to be with the life. But the one that really comes close to my heart, because her name is like my grandmother, Fatima al-Fihri, who established the first university in the world, in the Qayrawan in 850 something. So there are women, but unfortunately, great many books have been lost. There is also, I think Amira is absolutely right in saying, the men names come first. But many of the books, if you look closely at them, they will say, well, if it wasn't for Ruqayya, if it wasn't for a female name, if it wasn't for Maryam, I would not have been able to complete that work. So they were working
Behind the scenes.
behind the scenes sometimes.
Yeah.
Okay. Any other? Yes, please. Can I have a microphone here? Thanks.
Mona?
I just wanted to add to that point about women. My understanding is that women were very prominent as scribes in the universities, particularly in Andalusia. Do you have backing for that? That the women were used in the universities, particularly just
Okay,
to
that's fine.
educate.
Thanks.
Yeah, I mean, I think as librarians and copyists, yeah, certainly in Cordoba, there's evidence for women playing that role.
Anyone on this side? Yes, so over there, and then yourself over there.
Great.
Thank you.
So you talk about this culture of learning and of knowledge sharing in places like Alexandria and in Baghdad as being this golden age of education. Surely those have morphed into universities now. Do you feel, I mean, all of you have spent a great deal of time in universities. Do you feel that there is still that culture of knowledge sharing and progress,
Okay.
or not?
Do we have any students here? University
get a-
students?
Are you asking generally in all
Yeah.
universities, or are you asking in the regions that we're talking about?
In universities in general.
Oh.
So has that sort of culture that was prevalent in only a few cities in the ancient world continued to be more widespread in universities, or do you think that's disappeared along the way?
So I was just asking if there were any students in the audience. And do you feel that universities are places of knowledge sharing? Sorry.
In some ways, yes, and some ways, no. I think it depends what you do.
So why are you in
within
a university? Is it to get a degree? Is it to get a fuller education? Is it to get a job at the end? Is it all three of them?
Sorry? Can you repeat
Why
the
are you
question?
at university? Yeah.
Well, all three, really.
All three.
To get a job and to do some more learning. But I think universities these days is very, well, certainly the one I attend is very career-focused. So I would say there's a lot more emphasis on getting a job
the
rather than exploring the joy of learning.
Okay. Anyone want to take that question?
Yeah?
Yeah.
Actually, we were discussing part of that before coming in here, and Marcus is finding it very difficult to find students who will volunteer to come into festivals and exhibitions to just demonstrate the science that they have learned.
This is since the fees came in. I found that I used to get a lot of volunteers to come and do events with me, and since the £9,000 fees come in, students just feel they have to only do things to do with their course, which is kind of depressing. I mean, it's great because they're very dedicated to their course, but university is so much more than just the focus of what you're learning in your course.
Yeah. And then the second part of it is, for us, the academics, and particularly in the areas whereby you can invent something. I cannot exchange that easily nowadays. It hurts me, it pains me. But my superiors at the university, and I'm now free of them, thank God for that, man. They will say, well, have you patented that one? Because if you speak about that idea in a conference, it's not patentable. And unfortunately, many of our universities nowadays have become businesses rather than places of exchanging knowledge and having, I mean, I remember back in 1997 when I managed to get an electron to be bent to where I wanted it to be. And I had two of my colleagues from the Czech Republic around midnight, all in the labs, and it wasn't my wife, who was very generous and allowing me to be midnight in the labs. She's sitting in the audience, actually. Crazy, but crazy enough to be tried. And we went into silence for a moment. Great, we've got something nice. We wrote about it, but actually the finance officer, before I submitted the paper, said, that has got to be patented. So it is sad. So I'm saying it with a bit of sadness.
Okay. Let's take a couple of questions, and then I'll come back. The gentleman over there. But did you have a question as well? Next to, okay. There's a lady over there, and then over there. Thank you.
Why is it so acceptable to say, I can't do maths, in a way that you'd never say in public, that you can't read?
That's true. Okay, is that for me? Sorry, okay. It's not acceptable, and I think I said it only because I think that there is a problem with the way maths is taught in a way that, having said that, I mean, nearly 20 years at university, my expectations of even a university like Edinburgh are lower each year of what the students are coming in with. And this is students who come from very privileged backgrounds who you would think had a very good knowledge of basic English. But as I say, my expectation is getting lower each year. And that students are coming with A's, everything, but they cannot string a sentence, some of them together. And so maybe I'm wrong, maybe English is just as problematic in the way it's being taught. And maybe we are not realizing that by thinking about English in these kind of loose terms, that language, you pick it up, language is a living thing, it changes. We're not putting the same emphasis on what good language actually looks and sounds like. So I think there may be a parallel there as well, actually. No, I know, but they were silent, so I thought I had better answer that. So. There is, no, absolutely, you're right. But actually, if you think about it, there's a lot of people who can't read who are too embarrassed to say they can't read. Yes,
it is a badge of honour. People are quite proud to say they're rubbish at maths, which is why we need to reverse that cultural.
I certainly didn't say it with a badge of honour. I think I said it because
I
know. Yeah. But you're right that in certain parts of the world you wouldn't say it because everything depends on being able to do maths. Your kind of status in society depends on that. But I think there is a problem historically with the way we teach maths here and with the way maths is perceived. And I think even today, once a week at least on the Today programme on Radio 4, you'll hear somebody talking about the low number of graduates in maths, the fact that we need more maths teachers, and I struggle to find out why that is. Does it happen from a very young age, or does it kind of plateau off at a certain point?
Well, one of the troubles is that mathematics, in this particular environment, qualifies you to do almost anything you want to. So because education, we don't value teachers enough in this culture, whilst in other cultures they're celebrated as very important members of society. So people who are qualified to do maths will not come and do maths.
That's true.
Do you know the degree that most maths teachers have in this country? PE. Because a PE teacher gets a bit too old, can't run around with it, so they say, well, we've got an opening in maths. And so there's probably more PE teachers.
That's true. Just a couple of very brief questions then. Yeah, the lady at the back, and then yourself.
Can I just say, as a maths teacher, what I'm actually finding is when you verbalise a problem to a pupil and you make it relevant, they understand. But what they're expected to do is to actually answer a paper, and there's so much literacy in the paper, they can't extract that maths from the paper.
From the paper. That's interesting. Please, over there.
So you mentioned about the Golden Age of Islam, in an age where a lot of advancement were made in science by non-Muslims and Muslims. But what does it have to do with Islam, the religion, other than it being part of an Islamic empire?
Amira, do you want to take that? That easy question.
Well, I mean, that's a good question, and it's not an easy one to answer. But I think what I would say is that the Muslims as an emerging elite were very supportive of knowledge in that period. And I wouldn't say that any religion is per se, as a religion, for or against knowledge, but within the Islamic context, there are clear sort of indicators within the Quran and the Hadith that, the pursuit of knowledge is something meritorious, that's something that people should do. So you have a strong sort of impulse in this emerging empire as it becomes richer, as it controls more lands. There is actually a sort of a religious underpinning, if you like, or an ideological reason for supporting knowledge as well. So I think there is something of Islam in that, but that's not the complete story. There are a number of other different factors. You know, we've talked about political stability, wealth, the bringing of lots of different peoples from lots of different backgrounds together, and those things are all important, but it is within the context of a ruling elite who are Muslims and think knowledge is worthwhile and should be pursued, that this particular golden age, and there are, of course, many golden ages, comes to fruition.
Okay, thank you, Marcus.
One thing when we were making this program that came out that was connected was the keeping of time. That time has actually driven a lot of mathematical discoveries, because the nature of time is about pattern searching. And so if you look at the Mayan mathematics, for example, was about trying to navigate the stars. So I think that one of the things that it's very important, particular times of day, particular changes from one month to another being defined by things in the night sky, that there was, keeping track of when this would happen meant that you had, astronomy is a big driver for mathematical discovery. So you certainly find that sort of in ancient cultures, but I think it was also a driver here that to know precisely when the new moon was going to be there might have been a contributor.
I think I was just going to say, just to say briefly, history shows that when civilizations are confident in themselves, they allow knowledge to flourish. There's no boundaries. There's a deliberate desire to risk take, because you're not defensive, you're not inward looking. And when civilizations start to become inward looking, it's usually because they're unsure of themselves. And we've seen that history within many parts of the Islamic world, that now we're at a different stage. So I think that's partly to do with it as well. And that's not just civilizations, it's life in general. When you are feeling confident in yourself, risk-taking is good, it's attractive. Did you want to add anything, Mohamed?
The Quran in particular motivates people in that respect. The verse that I love reading and reminding myself with, إن في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب الذين يذكرون الله قياما وقعودا وعلى جنوبهم وتفكرون في خلق السماوات والأرض ربنا ما خلقت هذا باطلا. In the creation of heavens and earth, the cycle of day and night are indeed signs for those with wisdom, the wise, who contemplate and say, oh God, glory to you, you haven't created that in vain. So that was a driver, a motto for many of the Muslim scientists at the time, but also having the rulers that understood that directives and then allowed people with no fear, as Mona was saying, just get on with it. So there was no clash between science and religion in that respect. And I think Islam has benefited a lot when it was free thinking, no blinkers. People just go and enjoy life. You will only live on earth once.
Any other couple of questions? One there, and maybe one from that side? Anyone want to ask a question? Okay, let's take this one.
Hi, this sort of refers back a little bit to the question you were saying about English versus maths education. And my background is actually, I work with adult education, essential skills. And I get a real feeling that we're talking about people who are able to go to university or younger children who we are teaching at the moment. But obviously I teach people who are adults and have missed out a lot, and perhaps for lots of different reasons, on their education. Now, I'm from Wales, and the stats from Wales does clearly show that there is a huge discrepancy between literacy skills, essential skills, and numeracy, and there is a big gap there, and the impact that then that subsequently has on life choices across the board. Now, my question really is about, in the Golden Age, for me, from my experience, I don't see the sharing necessarily. It's still that elitism of that educational, and that, to me, that discrepancy, because of funding, gets wider and wider.
Yeah. No, that's true.
So my question is, in the Golden Age, was that the case there as well, that they had this big discrepancy, or was knowledge shared more generally?
Good question, thank you. Do you want to answer that?
Actually, if you look at a writer from this period from Basra, Al-Jahith, he actually talks a little bit about children's education and the kind of education they should receive. And he actually puts quite a stress on basic literacy, but also numeracy. He also talks about arithmetic, and this is just for ordinary kids. And in talking about his own education in Basra, in southern Iraq, he just has an aside about somebody being bitten in school one day, but he says it was the butcher's son. And I find that really revealing, because it means that, you know, sort of primary level education in these Islamic cities of this period was actually something that even a butcher's son would acquire. So it wasn't restricted. Obviously, as you went higher up through the system, it became more and more restricted to an elite who could afford the leisure time, if you like, to continue learning. But at least when it came to basic literacy and numeracy, there was a societal value put on that, even for people who would have quite practical trades later on in life.
Marcus, briefly.
One of the striking things was when these new ideas came into Europe, that Fibonacci wrote the Liber Abaci and told these new skills. Actually, the elite in Europe tried to suppress them because they realized that these were tools that anybody could use. They could keep track of the calculations that were being done by the money lenders. With an abacus, there's no record kept. With suddenly the numbers 0 to 9, the ability to do the calculations yourself. And so these numbers were banned, for example, in Florence, 12th, 13th century. They didn't want them because they saw it was a challenge to the elite. So it's interesting that these mathematical tools can empower people to take that away from the elite.
Thank you.
Yeah.
Oh, yes, absolutely. We're running out of time now, so first of all, let me thank my panelists for their time, for their wisdom. Thank you all. And I'd just like to end on 2 lines. In 2017, the golden ages of Damascus, Baghdad, Cordoba, Cairo, Isfahan, Agra, and Istanbul are now an undiscovered, distant memory. Lost in European conquests, colonialisms, and other cultural flowerings in other parts of the world. But as we look to the future, perhaps the best guidance was uttered 900 years ago by the mathematician poet Umar Khayyam in his Confession of Faith. Both you and I are born alike, though some may sink and some may soar, we all are earth and nothing more. Thank you very much.